Hi, my name is Leslie Rollins. I'm a graduate student at the University of Maryland, College Park, studying developmental psychology. Today, I would like to tell you about a study I conducted with my graduate advisor, Dr. Tracy Riggins, titled Developmental Changes in Memory Encoding: Insights from Event-Related Potentials. During development, there's an increase in children's memory for items and contextual details. Some researchers have argued that age-related changes in memory are due primarily to the development of retrieval processes. However, we believe that encoding processes likely contribute as well. This hypothesis has been supported by some behavioral results. For example, Getty and Angelini found that younger children required longer stimulus encoding durations to show similar rates of familiarity. To investigate the behavioral and neural development of memory encoding, we use the event-related potential methodology. Event-related potentials, or ERPs, reflect electrical activity of populations of neurons that is time-locked to the presentation of stimuli, such as pictures. ERPs can be used in memory paradigms to compare activity associated with successful and unsuccessful memory performance during encoding or retrieval portions of memory paradigms. In adults, ERPs at encoding differentiate later remembered and later forgotten or missed items. These differences are referred to as subsequent memory effects. In adults, ERPs also differentiate between the processes of recollection and familiarity at encoding. Recollection refers to our memory for contextual details, whereas familiarity refers to the overall strength of the memory trace. For example, if you're walking through the grocery store and you see someone who looks very familiar, but sometimes you just aren't able to place who they are or how you know them, that's an instance of familiarity. In contrast, when you remember who the person is, that you met them at a summer MATLAB course and that the person's name is Matt, that is an example of recollection. For our study, we compared ERP responses at encoding between 26-year-old children and 20 adults. First, participants were fitted with an appropriately sized EEG cap. Then, they were seated in front of a computer screen. At encoding, participants saw 120 pictures of animals, plants, and everyday objects, and performed 2 judgment tasks. For half of the pictures, participants made an animacy judgment, and for the other half, a size judgment. Following encoding, the cap was removed, and participants took a 5 to 10 minute break. Then they completed the retrieval portions of the study. During retrieval, participants saw the same 120 pictures they had encoded, in addition to 60 novel items. For each picture, participants were asked if they had viewed the pictures before, and if so, what judgment they made at encoding. Recollection was indexed by the participant's accuracy for the semantic judgment. These were sorted based on behavioral performance into 4 categories: remembered, missed, recollected, and familiar. The recollected items were those remembered with the contextual information, whereas familiar items were those identified as old but without the contextual information. Behaviorally, there were no differences between children and adults' item memory or rejection of novel items. However, adults were more accurate at recalling the semantic judgment made at encoding compared to children. For the ERP data, we conducted 2 types of analyses. First, ERPs were compared between later remembered and missed items. We also compared ERPs between recollected, familiar, and missed items. No differences were present between recollected or familiar items in either children or adults. We believe this result came about because we used an objective rather than a subjective recollection paradigm. Please see the discussion in our paper for additional details. However, in both groups, we did find subsequent memory effects, characterized by mean amplitude differences between later remembered and later missed items. For adults, this effect occurred in the 400 to 600 millisecond window. Consistent with previous literature, the mean amplitude to later remembered items was more positive than the mean amplitude to missed items. In children, the subsequent memory effect occurred 500 to 800 milliseconds post-stimulus onset. In contrast to the adult findings, at frontopolar leads, the mean amplitude to remembered items was less than the amplitude to missed items. We also conducted topographical analyses to determine whether different neural generators were engaged by children and adults during encoding. We found a significant difference in how children and adults processed later remembered but not later missed items. These results show that both children and adults show subsequent memory effects, but they occurred at a later time point in children. In children, they were in the opposite direction, and they seemed to be generated by different patterns of neural activity. This suggests that age-related changes in encoding processes, in addition to retrieval processes, may contribute to increases in memory performance with age. Thank you for taking the time to watch the video abstract, and we hope you enjoy our paper.